Good day everybody, I am Dr. Gitanjali Mahamunkar and let us begin with the next chapter in this lecture series, that is binary number system. In the earlier lecture we have seen introduction to different number systems. What is a number system? What are the types of number system? The first one was binary number system with base 2, where we have two distinct digits to represent a number in this number system, starting from 0 to r minus 1, where r represents the base or radix, and 0 to 2 minus 1, that is 0 to 1. So the digits in binary number system, that is binary digits, are called bits, from the word binary digits. Okay, and what are they? 0 and 1. These two digits or bits are used to represent any number in a number system, binary number system. Okay, now let us take for example a binary number 100111. Okay, each digit in this binary number, okay, has got some weight, because even binary number system is a weighted number system, as discussed in the earlier lecture. So if I take an example of a decimal number 9876, where 6 has got weight 10 raised to 0, 7 10 raised to 1, 8 10 raised to 2, and 9 10 raised to 3. Detailed explanation of the same can be found in the earlier lecture, so you can refer that. Here the digits carried the weight 10 raised to 0, 10 raised to 1 or so on, because the base was 10 in decimal number system. Here our base is 2, so the weight carried by each of the bit would be 2 raised to 0. Here this would be 2 raised to 1, 2 raised to 2, this would be 2 raised to 3, this would be 2 raised to 4, and this would be 2 raised to 5, right? So as I represented this as 9876, because I multiplied each digit with the corresponding weight, here I will be able to write this number as 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 0 into 2 raised to 3 plus 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 1 into 2 raised to 0. Okay, now if I multiply this, okay, and solve this rather, okay, I would get 32 for this, plus 0 plus 0 plus 2 raised to 2 is 4 plus 2 raised to 1 is 2 plus 2 raised to 0 is 1 into 1, 1. So this would give me 6 plus 1, 7, and plus 32, 39. So this would be 39 in decimal. So had I to convert a binary number into decimal, I have to simply multiply each of this bit with the corresponding weight and sum it up. I would get the corresponding decimal number. So here in short I have also told you how to convert a binary number into a decimal number, which we are going to also cover in the further chapter, where we will be learning number system conversions. But as of now, just remember that each bit in the binary number system has got weight. Okay, now here this is when you have a normal number, but what if I have a fractional part also? Like suppose this point, now this is a binary point 1 1, as in case of the decimal number we have sometimes fractional part like 0.52 or something like this. Similarly here we call this as decimal point because we are talking about decimal number system. This is called binary point, because we are talking in terms of binary number system. Okay, now what if I have a binary point? What would be the weight of the bits after the binary point? Now, as in our number line, we all know it is at the center we have 0. On the left hand side we have -1, -2, -3, and here we have 1, 2, 3, 4. Right? Here we reverse the number line. Here we, in case of the weight of these places, we write 0, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 4, 5. We go on increasing from left to right to left. Here we will reverse this, and the weight would be -1, 2 raised to -1, 2 raised to -2, and so on. So if I have a binary number in this way, 100,111.11, then the weight of this digit or bit after the binary point would be 2 raised to -1. This would be 2 raised to -2. So if the integer part of this binary number is 39, the fractional part would be 39 point, what would be this? 1 into 2 raised to -1 plus 1 into 2 raised to -2. That is 1 into this plus 1 into 4. 0.5 plus 0.25. Right? So 0.75. So this is 39.75 in decimal. I hope you have understood what I have done here. Okay, here I have converted this binary number into a decimal number. Okay, if I have an integer part and a fractional part, still I can assign weights to each of the bits in a binary number. Now let us move on to the next topic, that is MSB and LSB, where full form of MSB is most significant bit and LSB is least significant bit. Okay, now why is a bit in a binary number called most significant, and why a bit is called least significant? Take again the same number, binary number, where this would be the most significant bit and this would be the least significant bit. Let me number this as bit number 0, bit number 1, bit number 2, 3, 4 and 5. So this is B5 and this is B0, where B0 is the least significant bit and B5 is the most significant bit. Now if I convert this binary number into decimal, then as I have told you earlier, it is 39. Now let us change bit B0 of this number from 1 to 0. This would become 100,110. Now if I convert this to decimal, I would get 38. So the difference between these two numbers is just 1. But if I convert the most significant bit to 0, then I would get 000,111. That would be 7 in decimal. This is 39 in decimal. This is 38 in decimal. This is 7. The difference between 39 and 38 by changing the least significant bit from 1 to 0 is just 1. But if I change the most significant bit, that is B5, from 1 to 0, I get this number, which is 7. And now the difference is huge. So changing this bit, the most significant bit, would make a huge difference. But changing the least significant bit doesn't make much difference. Hence, this bit is called the most significant bit. So this is all about MSB and LSB. Now the next topic, in which I would just need to specify that bit is the one bit of a number, binary number, is the smallest unit of data in computer. And if I consider 4 bits, then that make one nibble, which is used to represent a BCD number or hexadecimal number, okay, in binary. Then if I take 8 bits, then that would make 1 byte. If I take 16 bits, then that would make 1 word. If I take 32 bits, then that would make 1 double word. So you can say 1 word is equal to 2 bytes, whereas 1 double word is equal to 4 bytes. So this is all about binary number system, where we have studied what is a binary number system. It is a number system with base 2, with bits, with binary digits, 2 binary digits, which are called bits 0 and 1, which can be used to form any number in a binary number system. Each bit in a binary number is assigned weight according to its position. Hence, it is a binary number system is a weighted number system. You can convert binary number into decimal number by multiplying each of the bit with its corresponding weight and adding them up. Then we have talked about MSB and LSB, that is most significant bit and least significant bit, and why it is so. Then we have seen the different conversions, like groups of bits, what are they called. Okay, that is all for today for binary number system.